I'm Priyanka Ravi. I go by Pinky. Do you want to say your name real fast?
Yeah, my name's Justin. We're both employees at Weaveworks.
So I am a developer experience engineer at Weaveworks.
And I'm a customer experience engineer. So our descriptions are there. And yeah, I just wanted to keep it simple and just jump right in, actually, since we have a long presentation.
Yeah.
We want to get you guys introduced to Kubernetes and GitOps. So later on in the demo, we're actually going to have a live demo. So if you can go ahead and start getting these prerequisites on your laptop if you would like to follow along. Don't worry if you don't have them set up. Pinky has it on her laptop, and we will be able to walk through that as well. So
Yeah, and just a quick thing, the demo just is right there too. So if you want to go ahead and look at that link, and then it has some links to install if you want to.
okay, so I'll just give another 5 seconds on there. Okay. Yeah, and now the next slide is just a quick what is Weaveworks. So yeah, we're a key partner with all the major infrastructures, and primarily we are deeply integrated with the open source community. Pinky here actually is with the OpenGitOps work group. So if you join those meetings, you'll actually be able to hear her speak at times. And we are actually backed by solid investors as well. Okay. And so just sort of getting right into it, intro to Kubernetes. I have this picture here of an iceberg just to sort of highlight, man, Kubernetes is deep. And if you can see, maybe you've seen other memes of these, and the iceberg actually goes much deeper. I just picked up the 3 first top layers, and the labels might not be all correct, but I think it is metaphoric to, as you get deeper into Kubernetes, you start figuring out, wow, there's all this complexity. Thankfully for this talk, we don't need all that technical knowledge, and so I'm trying to help you guys wrangle in just a working definition of Kubernetes so that we can help understand Pinky's part of the GitOps intro. So before I get started, I just want to take a quick poll out there. How many of you guys have heard of containers? You could put a hand up. Okay, great. And keep your hand up if you've used Kubernetes on a daily, either at your job or, okay, so for you guys, this will be a little bit of a review. How many of you guys have heard of GitOps? Okay, a little more of you guys. Great. Yeah, so whatever you answered, it's okay. This is the intro, so if you didn't know anything, hopefully after you will know something about Kubernetes. And so before we get there, I want to just move us back just a little bit. So Docker and containers, they came in and they actually gave us a good way to replicate our applications both on our laptops as well as on the production servers. And we're really happy because generally that means we have confidence over what application we're building and what application we're presenting to our end users. And so production is just as what we want it to be. But the problem with this is, yeah, what happens if a container goes down, right? We're still left with this same old problem where now it's us, right? It's you. I highlighted you because for the infrastructure engineers or even developers, maybe you're getting that on-call, right? Now you're getting up at night trying to fix this container. So what is it that's container brought? Does not solve this problem of management. And management I'm talking about are these things that actually Kubernetes tries to solve. So I'm thinking downtime, scaling. Kubernetes enters as actually to provide a framework to actually help us address those issues. It gives us a mean of actually taking care of scaling, failover for all your applications, right? And of course, it's not as simple as just, let's just put it on Kubernetes and these things will work. It does take configuration, it does take actually management of Kubernetes itself. But there is also a beauty to it where you can use a whole host of tools, and maybe you've been outside at the different booths and different vendors have tools that can be put on Kubernetes to help you assist in those issues. And so just going right into Kubernetes, this is the official documentation of the components that make up Kubernetes. You can find it at the link there. But what I want to highlight is what is a cluster made out of? And you see on the left side, there's the control plane. Every cluster has the control plane, and usually that's deployed on either one node or in a highly available system on multiple nodes. And there are other nodes that are connected to it, and those are called usually worker nodes. But what I want to point out today is actually the key connecting point in that control plane box is actually the API. So Kubernetes, you could think of it as just a program with the API exposed, and that is actually how we communicate to it, right? That's how we actually communicate through YAML. So you guys never seen YAML. YAML looks like this, and you'll see Pinky do a lot of work with the YAML in a bit. But this is the piece of code that or more like text, that we actually present to Kubernetes, and it has the software to actually process that and create it in the Kubernetes cluster. So this next slide sort of gives a description of the different Kubernetes objects. These are two of the most basic parts of it. Deployments, right? These are also written in YAML, and once given to the Kubernetes API, Kubernetes will try to actually create this object on the system. And so deployments actually help, if you see the hierarchy here, it helps to give us an organization over scaling and also for scaling of pods. So if you look at the pods here, pods are made up of multiple containers, 1 through n, and deployments are made up of pods 1 through n, right? And so these things, pods and ultimately deployments, they live on what is called a logical host, right? So when we go back to the idea of nodes, each node at the end of the day is a physical server, and so pods technically live on a physical server as well. So continuing on, just a quick intro into Kubernetes controllers. So we have deployment YAMLs, and they have this API. So how does Kubernetes actually respond to the YAML that it's given? It's actually through controllers. So some example I have of what a controller is that take a thermostat, right? You have a thermostat, and you set a temperature to it, then it turns the room to that temperature. And so that's sort of what a controller, and you can think of the controller that way, where you provided a YAML, and it's going to try to make your Kubernetes cluster into that, it's going to create that YAML in the cluster. So yeah, the thermostat acts to actually bring the current state closer to the desired state, either by turning equipment on or off, right? And Kubernetes itself has a lot of built-in controllers. If you see there's a deployment controller, replication controller, namespace controller, endpoint controller, and all of those things are, mapped back to objects, Kubernetes objects, and those are all built in and given to you when you actually use and install Kubernetes. And so I bring up this point because when Pinky's going to talk about her GitOps portion, we will be using Flux, and Flux is actually also a collection of these controllers, but they're actually custom controllers. And I've made a note of that in that lower right corner. Okay, and so this is just another slide about all the different objects that exist in Kubernetes. One I wanted to highlight is namespaces, and that actually helps to provide a mechanism for actually isolating your objects in your cluster. And then the other ones there are also given to us to help solve different problems, problems that Docker containers themselves do not solve. So that is there. And then this last one that I have is just a representation of all the different objects, and they just live in your Kubernetes cluster, right? And they represent the state of your cluster. I have it there on the top right. It says, is your cluster desired state? So you provide all of these different YAMLs, and they interact with the Kubernetes API via controllers. And then from the command line, you use a tool called kubectl, which is the command line interface for interacting with Kubernetes, and it actually creates those objects for you. And so then Kubernetes has come to sort of give us this framework to help solve containers issues, namely scaling and downtime, right? But now what happens when someone changes your desired state, right? Say you have your production server, someone accidentally fat fingers a letter and your production system goes down. How do we actually reconcile that? It's still sort of that idea of, oh, you have to get up and fix it. Well, actually now this next part for Pinky, she's going to go over is where GitOps is going to help keep our cluster desired state in a desired state. So I'm going to kick it over to Pinky, take over the next place.
Okay. So I know a lot of people had already heard of GitOps, but has anyone actually heard of specifically Flux? Oh, Okay, a few. That's cool. Okay, so we're going to give like an intro into what is GitOps. So GitOps is an operating model for cloud-native applications such as Kubernetes, but it's not really limited to Kubernetes. If you are doing a multi-cloud infrastructure, you can still use GitOps, but because we're going to be talking about Flux, we'll be more focused on Kubernetes. And it basically utilizes a version-controlled system, most commonly Git, as the single source of truth. You're already storing all of your like YAMLs and your YAML files in there, so you might as well take advantage of it. It enables continuous delivery through automated deployment, monitoring, and management by a version-controlled system. And the idea is that you manage your infrastructure and applications declaratively. And there is a group, as Justin mentioned, called the GitOps Working Group. And this group actually created these GitOps principles. So they interviewed a bunch of end users, just like, best practices, and they came up with these little guidelines. The first one is that a system managed by GitOps must have its desired state expressed declaratively. So the idea with that is that if things are written in code, then, they're reusable, there's an audit trail, there's really like, everything's written out. The second one is that desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. So there's no sneaking in a change. Everything's, documented. And then software agents can automatically pull the desired state declarations from the source, and software agents continuously observe actual system state and attempt to apply the desired state. So basically, something is ensuring that what you have declared as your desired state is what's actually out in production or whatever your environment is. And don't feel like you really have to, have all of these met in order to use GitOps. Everyone's journey looks different. These are just a set of best practices and guidelines that you can, tweak to meet later as well. So, yeah. What is the benefit of GitOps? So, because GitOps it has the unique ability to treat everything as code, it creates a direct impact on security. So, if configuration and security policies are treated as code, then everything can be held in version control, and any and all changes that are made are reviewed and input into this automated process. So there's no manual processes. Your team is less likely to be at work on a weekend just because of some error in a manual deployment. And then all of these benefits that are listed here as well. So now I'm going to go into what Flux is. And so Flux is a Git-centric package manager for your applications, but Git isn't the only source that you can use. And it provides a set of continuous and progressive delivery solutions for Kubernetes. It was created literally with Kubernetes in mind, so it's a supernatural extension of the benefits of Kubernetes. And what it does is, at the core, it continuously monitors your version control system, and it applies the desired state that's been declaratively stated there. The nice part of this is that you don't have to worry about configuration drift because it reconciles on a set schedule. And so if things for some reason have gotten out of sync, then it will actually set it back to your desired state. And it really reduces developer burden because it removes the need for a manual deployment process. And also the CLI, so the command line tool for Flux, is a really convenient way, which I'm going to show in a second in the the hands-on part, to get started with it in a cluster, and to also access the custom resources that make up the API as well. So, these are some things that we like to say on our website. So, an introduction to Flux, basically, too, before I keep going on with it, is that Weaveworks created it, and then we donated it to the CNCF. And if you're not familiar with that, it's the Cloud Native Computing Foundation. So that's the story of Flux. So it's fully free and open source. Okay, so Flux provides GitOps for both apps and infrastructures, and also using Flux and then another application also that's in the CNCF called Flagger. You can deploy apps with canaries, feature flags, and A/B rollouts, so progressive delivery stuff too. And Flux can also manage any Kubernetes resource, and infrastructure and workload dependency management is built in. You just push to Git, and Flux does the rest. And like I said earlier, it manages deployments through automatic reconciliation. It works with your existing tools. So it works with your Git providers like GitHub, GitLab, Bitbucket. You can even use S3 compatible buckets, Helm repositories, and OCI repositories as sources. It also works with all major container registries and all CI workflow providers as well. Flux works with any Kubernetes and all common Kubernetes tooling. So it works with Kustomize, Helm, RBAC, and policy-driven validation, such as OPA, Kyverno, admission controllers. It basically just simply falls into place with whatever you're already doing in your Kubernetes ecosystem. It also does multi-tenancy, and as we like to say, multi-everything. It uses the Kubernetes RBAC via impersonation and supports multiple Git repositories. You can do like a multi-cluster infrastructure, so what Justin was talking about earlier with like a Kubernetes cluster. You can set it up to actually manage multiple clusters. And apps also work out of the box with Cluster API as well. Flux can use one Kubernetes cluster to manage apps in either the same or in other clusters. It can spin up additional clusters itself and manage clusters, including lifecycle and fleets. It also alerts and notifies. So there's some really cool features built in where it can provide you health assessments, it can alert to external systems, and it can also do external events handling as well. You can simply just git push and then get notified on Slack and other chat systems as well. We like to say users trust Flux. So my history is actually, I used to work at State Farm up until December, and I actually set up GitOps at the company, and along with my team, and I was the lead for the Kubernetes platform. So I worked on, that's my experience with Flux as well. And the community is super, super awesome. We welcome contributors as well of any kind, even beginner contributors. And the components of Flux are on Kubernetes core controller runtime. So anyone can contribute, and its functionality can be extended very easily as well. So the benefits of Flux are that it reduces developer burden. So Justin mentioned kube control, and kube control can kind of be a pain sometimes because you have to worry about which kube control versions you're on to be able to interact with the cluster. And with Flux, you don't have to worry about that. You get away from that issue. Also, Flux is super extensible. It's really versatile. It works with existing tools. And it's really flexible. So it's built on a microservice architecture, controllers, which Justin mentioned. And so you can really pick and choose what you want to use to tailor your own experience with it. So this is the controllers that make up Flux. So as Justin mentioned earlier, controllers are things to handle the life cycle of objects in Kubernetes. First we have the source controller, and the source controller is the one that's going to be listening to your source that you set up, so like your Git repository, for example, and it fetches resources and stores them as artifacts from there, so like your YAMLs. And then the customized controller is then going to apply those manifests, and it runs manifest generation using Kustomize. So if you're familiar with Kustomize, it's basically a tool to do like overlays and like all these other fancy things with YAMLs. And so if you are using a Kustomize .yaml, the Kustomize controller will look by default at that. If you're not using it, it'll actually use Kustomize in the back end. And what it does is it'll recursively search the path for any YAMLs that you have there. So, and then apply them all. So, and then the Helm controller does deployment of Helm charts. So if you're using Helm charts, and if you're not, I recommend looking into them. They're fantastic. And so that does deployment of that. And then the notification controller does notification dispatch. So it specializes in handling inbound and outbound events. So that's the controller you would use to set up like things like notifying you on Slack or whatever. The image reflector controller reflects image metadata for automation controller. So it's basically watching a image repository for any like new version changes. And then the image automation controller actually updates your YAML when new container images are available. So they basically work together to update a Git repository when new container images are available. And all of these controllers are running on schedules. So they're all doing things constantly. Like let's say if you set it up to do every 5 minutes, it's checking your source, every 5 minutes the customized controller's applying them, so on. So, Weave-GitOps, so there's a few add-ons, Weave-GitOps being one of them, and this is not automatic, like it's not under the Flux project, but Weaveworks created this free and open source UI, so it adds a web UI that surfaces key information to help application operators easily discover and resolve issues. It's a pretty neat UI. It's super intuitive, and it provides a guided experience to build understanding and simplify getting started for new users. It also shows like a graph of your deployment, and within it you can actually force reconcile, like let's say you don't want to wait 5 minutes for the change to be picked up, you can force it to do so, things like that. And then this is the links to, so the first link is for the actual repository for this project, and then the second one is like a guide. It has a guide to like getting started and all the documentation for that too. Another add-on we have is the, I'm going to show this one a little bit in my demo too, but it's the GitOps Tools for Flux Visual Studio Code extension, and it's like really awesome. I use it all the time. It is more focused obviously towards developers, so people who are using VS Code. It's super intuitive as well. It's really nice for managing your deployments also. And it does something similar in the sense of like you can actually force reconcile from there as well. But I will show it in the demo because it's really awesome and I love it. But yeah, so you can get it at the, that's the first link is also where you'd find it in GitHub. And then the second one is to actually find it in the marketplace so you can download it and use it as an extension. Okay, so like I said, the demo, if you want to like follow along or if you want to do it later, is at bit.ly/flux-ato-demo, and it takes you to my GitHub gist. And so it has like all the commands and stuff to follow along there. Okay, and for it, there's like some prerequisites. I can go to the thing, hold on. Okay, so this is what the gist looks like if you don't feel like going to it now. But so if like some prerequisites are, we're going to be using Kind. So Kind is Kubernetes in Docker. So it's using Docker to just set up a little Kubernetes cluster on your local computer. That you can just play around in, which is really awesome if you're just testing some basic stuff. So the downside to it, I guess, is that you have to have Docker installed on your computer. So easiest way to do that is install Docker Desktop. Also in this demo, you need a GitHub account. You need kube control. Well, you don't need kube control, but it's nice to have, and the Flux CLI as well as Kind, which is also a CLI. Okay, so. And if you're on a MacBook, you can just brew install Flux and Kind as well. So yeah, I've already installed them. I'm going to run this command. So this is to stand up the Kind cluster. Is this too small, by the way? Yeah, okay. Okay. Tell me when. Oh, and it's gone. Good? Yeah, okay. All right, cool. Okay, so that's going to create us a Kind cluster named Flux. And then I'll make this one bigger too, sorry. So we'll just give that a second. And if y'all have any issues or questions, you can raise your hand, and we have some people in the room actually from the company that can help you if like you're having issues with, if you are following along. So just feel free to raise your hand at any time. Okay, so that's done. And then we'll do, so the Flux CLI, as I mentioned earlier, can run this thing to set it up. It's called Bootstrap. But Bootstrap requires permission to push to GitHub. So you need to set your GitHub token as an environment variable in your CLI. And if you don't know how to get that, you go to your settings in GitHub, you go to, developer settings, and then it's under personal access tokens, and you just like generate a new token, and it's this classic one. So that's how you do it. And then you copy the one it gives you, and so that I've already exported these two. And then GitHub owner is your GitHub like username. So for me, it's Priyanka-Ravi. So like this part. Okay. So then you grab this command, which is the bootstrap command. And the really cool thing about this command is that if this, so, whoa. Okay, so can you all see this? Yeah. So if, where it says -- owner, that's like under my GitHub namespace. And then it's saying create a private repository called Flux-demo. And it's saying listen to this clusters / my cluster path, or bootstrap into it at least. And so what it's doing is if the repo doesn't already exist in your GitHub account, it will actually create it. And then it will clone it, create the manifest needed for Flux, and then push it back up to your repo. But if the repo already exists, it'll just bootstrap into the existing repo. And then the neat thing is, once you've already bootstrapped, if you update the version of the Flux CLI to like the latest, and then rerun bootstrap, it'll actually update your Flux manifest as well to the newest version of Flux, which is like a really easy way of getting like updated to the next version of Flux as well. So, and then this is waiting for the customization. So as I mentioned earlier, the customization controller is the one that's actually applying all the manifests. So it needs to finish applying and then make sure everything's healthy before it'll like actually say like it was successful. So that's what it's doing. But while that is doing that, we can go and look at the repo. If I refresh this now, we have this new repo that was created 2 minutes ago. And we can look in here. So you see that cluster's my cluster path that we told it to bootstrap into. First thing is this. So this is that customization I was talking about earlier, the customization.yaml. And what this is saying is, regardless of how many YAMLs are in this folder, only go and apply the two that are listed here. So GOTK components and GOTK async. So if there were any other ones, they would all be ignored. And then GOTK components is a YAML with like, it creates the Flux system namespace, which is where like, everything gets stood up, like all the Flux controllers. And then it also has all the CRDs, the custom resource definitions that are needed for Flux to work. And then all of the actual controller manifests as well. So all of the YAML to actually stand them up. Okay, so GOTK source, this is actually how to interact with Flux or how to tell Flux to install things. So the first part here is the Git repository, and this is the Git repository source. So what this is doing is it's telling the source controller, hey, go listen to this Git repository that's at this URL. And it's saying to actually apply on a 1-minute sync. So every minute, go and check this repo for, just like for any manifest. And then the customization controller is coming in and saying, hey, every 10 minutes, go and apply everything that's found under the cluster's my cluster path within that source that's created above. So that's how this is working. So this is telling the customization controller to then go apply every 10 minutes, like what's in this folder. So that's how that works. All right, and then we can get, so we can run like K in my case is alias for kube control. Sorry, that's a habit of mine, but that's a kube control command. So if you type in KUBECTL, same thing. And so I'm just getting the pods that are in the Flux system namespace that we just created, and you can see like all these source controller, all these controllers were stood up. So yeah. So now if we go back to the demo, we can clone the Flux demo repo that we just created. And then we're gonna make this directory called test. And the point of this is, so there's this create tenant command in Flux. And as Justin mentioned earlier, there's a concept called namespaces within Kubernetes, and they're like he said, tenant isolation. And so this command is going to actually create us, well, in this case, it's exporting it, but the Flux create tenant command actually creates a namespace, a service account, and one other thing. We'll see it right now. But so the export part of that command is actually saying don't actually create it, but instead output it to a YAML so that I can actually properly, like with the GitOps mentality, push it up as code. And so it's the role binding. So that's what I forgot. It's the namespace, service account, and the role binding. And the thing that the service account and role binding are doing in this case is they're actually creating tenant isolation for you. And so that's a really cool thing. It's like, so if you're worried about someone, coming along and using Flux to deploy things to other namespaces, this takes care of that. That's what the create tenant command is good for. Okay, so now that we have that, I am going to actually push it. Okay. And then there's a pod info deploy repo, and it's just like super, super simple. It's just a back end and a front end like application. And the front end's just like a very simple UI. And we like to use this application for like demos like this because it's just an easy way of showing like how to set something up. And then, okay, so with that, we are going to then, within our new test repo, we're actually going to create a source. So exactly like what I showed earlier, we're gonna create a source, and this is like just using the Flux CLI still. To do so, but you can also just like type this code out if you want it in YAML. And then we're gonna add the customization as well to tell it to listen to that pod info repo. So you can see here, it's actually pointing to the pod info repo, and then we're telling the customization within that repo to actually just apply everything, whatever's in that /. So there's the customization.yaml there. And then we can see what that YAML looks like now. So you can see it's like what I showed earlier. It's just a simple Git repository source and a customization as well. So this one's telling it every minute to go and apply the customization. Yeah. And then I'm going to add that too. Okay. So now we can reconcile. So we can run this command, which is flux reconcile customization flux system. -- with source is like saying, hey, go reconcile the source first. But the key thing to know here is actually if the source controller picks up an actual commit shot change, it will trigger the customization to also reconcile as well. So in this case, I could have just done a reconcile source, but I just wanted to show that command because it's not like a very well-known command. And then we can do a flux get source get -a. So, whoops, I hit a /. Did it again. Okay. So this command is saying like within all the namespaces, go get the get sources. And so we can see now that there's also this pod info one. So the flux system one is the one that when we bootstrapped was created, but the pod info one is the one we just created. And then we can also do a get customization -a, and that gets all the customizations within other namespaces. So we can see like, this one's tied to test and that one's tied to Flux system. So, and then, you can also see like, did it successfully apply and stuff like that as well right here. And then we're going to port forward because of that small little application. We're gonna just run a kubecontrol port forward command. Simple, so now it's handling the connection for us. And we can now hit this. Yeah, so you can see this small application has been stood up. And then if we go back, and then go to, okay, so, sorry. We can go into Visual Studio Code now. And let me make this bigger too. Okay, so in this UI, we have this very like, you know, basic, sorry, let me refresh these. So remember I mentioned earlier that Visual Studio Code extension? So that's what you can see here on the left-hand side. And it shows you like all the sources. So basically that thing, same thing I showed with like Flux get sources. And Flux get source get, sorry. And you can do like, you can reconcile it right here. Sorry, that's really small, but that what I'm hovering over says reconcile. And then you can also like suspend it. So let's say you make a change in Git and you're like, I do not want that change to go in. And oh goodness, I just know this is gonna fail badly. So you can actually suspend it and temporarily pause any changes from going in. And then you can, when you're ready, like if you fix the bug, you can actually resume it, or resume it and then force reconcile it as well, right? So you can do that with both the customizations and the sources in here as well. So that's really cool. And then what we're gonna do is we're just gonna change the UI color in here to something super simple, basic, and we'll do a then we'll push that. And once that's pushed, you will see, well, we can just go in here and say like, you know, reconcile this and reconcile that. Give it a second. And then we might have to restart the connection too. Maybe the source didn't reconcile in time. Yeah. So I just had to cancel the connection and restart it because it's locally and running, right? So anyway, so I rerun it and then it's there. So Flux did pick it up. I didn't do anything with Flux. And then if I go in and so let's say somebody comes in and they like accidentally delete a pod. So you can come in and like grab this delete this pod completely. And if you give it some time and you do control get pods dash n test dash w. So this is watching, oh, I missed it. So you can see that 9 seconds ago, the UI was actually stood back up. So that's because when I deleted it, Flux noticed that it was gone and actually just like remember I said every, I think, minute in this case it's running. So it actually hard set it back to being set. So that is what happened there. And that is all I have to demo. We have like 5.5 minutes. If anyone has any questions, Justin and I can answer them. I think we have one back there. Does this one work too?
I think it should work.
Yeah. Okay.
I think he's trying to get it working.
Yeah. Thank you. Yeah.
See, most of the stuff we able to do in Git actions, right? So Git actions.
Okay. Yeah, so I can answer this because like at State Farm we were using GitLab CI, and I can understand, like, so the real thing here is that one, there's a pull versus push model that comes into question. So with GitHub Actions, you're using a push model, And with Flux, you're using a pull model. With GitOps in general, you're using a pull model. And the idea is you don't have the benefit of the continuous reconciliation if you're using GitHub Actions. So you lose out on like the ability of like configuration drift or disaster recovery, because with GitOps, back up like, you know, your deployments is instantaneous. It's within minutes, right? Whatever that reconciliation is set to, 5 minutes. You saw that when I deleted the application altogether, it stood it back up in a minute. GitHub Actions won't do that because it's a one-time action.
Yeah, but still, like, if I hook them into the Terraform, I can still get back that.
So, interesting you mentioned Terraform. Flux actually has an add-on that's actually the Terraform controller, which actually also does a pull model for your Terraform resources, which is really awesome. So Terraform is, again, the same way. Terraform's not checking your live state. It's actually checking your state file by default. So the Terraform controller is really cool because it checks your live state every 5 minutes. And if something gets out of drift, it'll actually set it back up. So it's still better.
Yeah, okay, yeah. Thank you.
Yeah, good question, though. We get that a lot, actually.
Who's next? All right, so it's after 3 o'clock in the afternoon. You guys have had lunch. Everybody is going through the post-lunch slump. So we're going to ask you some questions before you get to ask some questions. Why did the Java developer need glasses?
Knee glasses? I don't know.
Because he can't see. All right, your turn.
That one was rough.
So I guess my question's more around preference. So we've recently implemented Argo CD versus
okay.
Flux.
Okay,
So I
yeah.
guess what would your argument be to use Flux over Argo CDs?
Okay.
Benefits, cons, etc.
Right. Yeah. Okay, so they're both fantastic tools, both really good GitOps solutions. So we do work, like, you know, we're friendly with them. The differences are that Flux, or at least the benefit towards Flux, like I as a user have never used Argo, so I can't really say. But Flux actually has better Helm support. With Argo, it ends at like Helm hooks, but the Flux like controller, the Helm controller actually uses the Helm SDK, so it has better lifecycle with Helm. Another thing is the new OCI support that Flux added. Flux can actually connect now to an OCI registry as well, which is like a big thing that we're very excited about. And then also the Terraform controller, like I mentioned a second ago, it's really exciting. Argo doesn't support Terraform as like a manifest that it can deploy, but with the Terraform controller, you can actually do that with Flux.
So with Argo CD, you get the web UI.
Yeah.
So, but if you were to use Flux, you'd have to use Weaveworks as a kind of like the
Yeah,
front end for that.
You install WeaveGitOps through a Helm repository, and again, it's free and open source, but you just add it like as a Helm. I didn't show any Helm installations, but they're really easy to set up. You just set up a Helm repo and a Helm release, and it's really simple. You can put your values in there as well. So, yeah. Did you
Okay, thank you.
Okay.
Yeah, I was going to say, do you guys have it for him to see if he would like to?
We have 45 seconds. I don't think we have enough time.
Yeah.
But if you do want to see it, you
In
might be able
person,
to,
yeah.
you can chat with them. Yeah, it's really cool.
You guys did an amazing job. One last question.
20 seconds?
Yeah.
It's okay.
Before we get to the questions, what is your favorite key on the keyboard? Do you have an answer? He said backspace, you guys. Mine's F5 because it's so refreshing.
So I'm more from the development background,
Yeah.
but we face challenge with the pipelines, CI/CD pipeline, deploying code all the way to production. So can Flux anyway help with this CI/CD?
Absolutely, yeah. That was our issue at State Farm too. We wanted to get away from like the whole pipeline deployments. And yeah, it's super easy to set up. We used it in production as well. Yeah, Yeah, the answer is just yes.
So like very quickly, we have like dev account, test account, prod account. They are on EKS. So like we
Yeah.
deploy to dev, and then how do
Yeah.
we? And then we promote to all the way to prod.
Right.
On the EKS.
You could use Flagger for like if you had specifically like progressive delivery, like but also you could just have multiple Flux. Is what you're gonna say?
Yeah, separate.
Yeah, some separate Flux deployments on each of your cluster. You could even use multi-cluster infrastructure with Flux, but the way we did it is we had separate Fluxes set up on our different like clusters for because we had like one prod cluster, one prod backup, you know, that kind of thing, and one staging, one infra. I mean, one can't think of the word test, like you said. And so we would have like a Flux set up on there that was listening to a repo. We specifically used a separate config repo for our actual production deployments. So we had like our source repo with like, you know, like where we were running tests and everything. And then when something was actually ready for production, it would kick off to our separate production repo where the manifest would be put. And then our production Flux was actually listening to that repo because we had like audit and compliance requirements because, you know, State Farm, lots of red tape. And so we had like a manager approve on that separate repo.
So
Yeah.
like if we build an image and push it to the repo, then same image if we want to deploy all the way to prod, that's what I was going.
Yeah, yeah, and actually the image automation controller is really good at that too. Something definitely to look into. It's really awesome. Yeah.
Thank you.
Yeah, no problem.